This is Unit 3, Lesson 5, Example 4. So given the triangle WGE on the axes below, apply the translation T subscript 1, comma, negative 2. So that means in the x direction we are moving positive 1, which is to the right, and in the y direction we are moving negative 2, and again negative in the y is down. So right 1 unit, down 2 units. It asks us to graph, label, and state the coordinates of our image. So we're going to have a W prime, we're going to have a G prime, and we're going to have an E prime pair of coordinates. And again, I'm going to apply this graphically. So I'm going to move to the right 1, and then I'm going to move down 2. So here is G prime, and that coordinate is 1, 2, negative 3, comma, negative 2. Right. So again, I can apply that transformation to each point, that translation to each point, or I know that G and W are 2 units away, so G prime and W prime are 2 units away. And that gives us negative 3, comma, 0 for W prime. And again, I can either use the distance being maintained between W and E for W and E prime, or I can apply the translation. 1 unit to the right, 2 units down. So we have E prime right here. And I connect those to form my triangle, W prime, G prime, E prime, and the coordinate for E is 1, comma, 1. They want us to draw and name the vector that maps the pre-image to the image. So we are going from the pre-image point to the image point. So one name for the vector would be W prime, or I could have done G to G prime. So that would be vector G prime. Or I could have done E to E prime. So that would be vector E to E prime. And again, a vector is just a ray. So on top, to name the vector, to name the kind of figure it is, I put a ray on top. Again, the endpoint, where you're coming from, should go first, or the tail of the vector, and where you are headed, or the head of the vector, is where you're going. That should come second, just like you would label a normal ray, which we discussed in Unit 1. Is orientation preserved? Yes. If I look at the first figure and start at W and go clockwise, I have W, E, G. And if I start at W prime on the image and go clockwise, I have W prime, E prime, G prime. So since these two orderings of W, E, G and W prime, E prime, and G prime are the same, we know orientation is preserved. We should also know at this point that the only transformation that does not have orientation preserved is the reflection. Is parallelism preserved? So let's take a look. If I extend WG out with W prime, G prime, these two lines are the same distance away and will never intersect. So yes, parallelism is preserved. Is triangle WGE congruent to triangle WG prime, E prime? Yes. Triangle WGE is congruent to triangle W prime, G prime, E prime. Explain. A translation is a rigid motion. Meaning, right? Meaning sides and angles are unchanged or congruent, to use our specific geometry vocabulary. And that is all we have to do for this example.